that list the results of a for loop. So we'll do for I in range n, and we'll call the append method on the result object, I to the second power. And then I'll backspace back a level because we need to use return now to get result out of the function. Alright, 2 strokes of enter and we're back. This time my name is going to be B, and I'm just going to pop in 4 just like we did before, this time into the IT square function. If we echo back B, look what's happening. We just get the whole result of the iteration in one shot. And you know just by those square brackets what type B is, don't you? Let's finish our consideration of generators by now looking at generator expressions. A generator expression is directly analogous to something we've learned about earlier in the course, the list comprehension. Just by way of review, remember that a list comprehension or a list comp is a data structure that looks like a list, that's because it is, remember the square brackets, that represents a shorthand notation for building a list through an iteration. So our example here, we define a name called LC. We're specifying an operation, I to the second power, for I in, and then in this example I'm doing range 10, but you could also have any other iterable assigned to a name, let's say, or whatever, and you would just swap that in here. Range just serves as a really nice grist for the purposes of our example. And you'll note that if we echo back the object or the value associated with LC, of course it's a list that matches this sequence. Range to 10, take the square of each value, working your way up. The analogous way to go with generators is to use a generator expression. Now syntactically it's just about the same as a list comprehension, but notice that we're using parentheses instead of the square brackets. You know what a paren is, right? A paren always lets us know that we're dealing with a tuple object. So in this example, we're creating a name called gx, and in our parentheses, it's essentially the very same operation, isn't it? I to the second power, or I squared, for I in, and then here I'm using the range notation where instead of just giving the topmost value, I'm providing the initial value and the top value. It's up to you which of those notations you want. Now notice what happens if we echo back the value of gx. Again, it's a generator object. So you guessed it, we can use the next function to retrieve those results one at a time, or we could just do a for loop and bring them back all at once. It's up to you. But remember that generators in general are known for being really conservative in their memory footprint. It's sort of like a garden hose where a list comprehension is just turning it on and the water comes shooting out. Whereas with a generator function or generator expression, it's like you have a handle or a nozzle on that hose where you can control the flow of that stream. To demonstrate generator expressions, we're first going to contrast them with list comprehension. So let me create a simple list comp. That again is very similar to what we did in the whiteboard. Here I'm going to take 2 to the I power for I in range 15. And of course syntax error. Those are the easiest errors to catch, right? At least in most cases in Python they are. I was missing the assignment operator. So if we echo back LC, we get our list object. We already know it is of the list data type. All is well and good. There's the list comprehension. Now, to turn our attention to generator expressions, how can we do that? In this example, I'm going to build a simple list that'll serve as our iterable sequence. All right. And then for our genexp, I'm actually going to call this genxp. Remember, we use parens instead of square brackets. We're going to do an I for I in ML if I is greater than 10. So we're going to run through ML, gather just the data value. We're not going to square it. We're not going to do anything like that. We're just going to get the raw value. But our condition here is a little different. We're only looking for values that are above 10. So we're expecting to see 16, 32, and 64 here, aren't we? As expected, genxp returns a generator object. Same with print. So to get data out of this, of course, we can go a couple of different ways. We can invoke next, passing in genxp, 16, next, genxp, there's the 32, next, genxp, there's 64, and you know what's going to happen now, right? We get our stop iteration. Now, if we want to bring back all of them, we can still do that. We'll just invoke another loop. For j and genxp, give us j. One more time with feeling and spelling the name correctly. Now what we're seeing here, friends, is a failure in this for loop, and the reason for this is known and documented. Generators can't be rewound or reset. You'll recall that we used the next here to go through that sequence based on our generator expression.